Ever wondered how your car can go from highway speeds to a dead stop with just a tap of your foot? Today on Knowledge Hub, we're opening up the entire braking system to show you exactly how hydraulics, friction materials, and clever engineering work together to deliver the stopping power you rely on every single day. When you press the brake pedal, it doesn't directly squeeze the wheels. Instead, it triggers a hydraulic chain reaction. At the heart of this is the master cylinder, a sealed chamber filled with incompressible brake fluid. As your foot pushes the pedal, a pushrod drives pistons inside the master cylinder forward. Because brake fluid cannot be compressed, this motion instantly builds hydraulic pressure. Pascal's law kicks in here. Pressure applied at one point in a closed fluid system spreads evenly throughout, meaning a small force from your foot is multiplied into enormous clamping power at the wheels. That high-pressure fluid is routed through steel brake lines and reinforced rubber hoses to each wheel. At the end of those lines sit the calipers, precision machine clamps that house one or multiple pistons. When the pressurized fluid enters the caliper, the pistons extend outward and force the brake pads against the rotors. And these rotors, or brake discs, are the real battlefield where the car's kinetic energy is destroyed. Rotors spin with the wheel, and when the pads make contact, friction converts kinetic energy into thermal energy. In heavy braking, rotors can climb past 500 degrees Celsius, which is why many rotors are vented with internal cooling channels. High-performance cars even use drilled or slotted rotors to help evacuate hot gases and maintain consistent friction. The brake pads themselves are engineered like miniature heat-proof machines. Organic pads offer quiet operation, semi-metallic pads provide high bite and durability, and ceramic pads deliver stable performance at extreme temperatures with minimal fade. Behind the scenes, multiple subsystems keep everything consistent. ABS, the anti-lock braking system, uses wheel speed sensors and a rapid-fire hydraulic modulator to prevent wheel lockup during emergencies. Electronic brake force distribution intelligently shifts braking pressure between front and rear wheels as weight transfers forward. Brake assist systems can detect panic stops and automatically boost hydraulic pressure to shorten stopping distances. And newer brake-by-wire setups even replace traditional links with electronic sensors and actuators, allowing ultra-precise control and integration with stability systems. All of this engineering works toward one mission: turn a moving car's energy into heat without losing control, without fading, and without delay. It's a perfect balance of physics and mechanical design, hiding right under your foot. If you're enjoying these breakdowns of everyday technology, don't forget to subscribe to Knowledge Hub for more deep dives, and as always, stay curious.